Hey guys, today we're going to continue our conversation about alternate ways to solve quadratics. The last video, hopefully that you watched, was about substitution method. This is elimination method. It's just an alternate form. For substitution method, we had a y or an x already solved for. Elimination method is what we're going to use when a y or an x isn't already isolated. Okay. So again, just bear with me on the verbal instructions and then I'll do a few examples. So for elimination method, the first thing you need to do is you're going to have to decide which variable do you want to eliminate. Do you want to eliminate all the x's or all the y's? Okay. Once you choose what variable you want to eliminate, we are then going to multiply one or both equations by constants to obtain the same coefficient but with opposite signs. Now you're going to add the revised equations and solve for the remaining variable. And now from this point, it'll be just the same. Sorry, didn't mean to do that. From this point, it'll be the same as the last lesson of maybe I get x equals 5. I'm then going to plug that value into one of the original equations to solve for the other variable, and then I'll write my solution as an ordered pair. Okay, so if we look at this first example, 4x plus 3y equals negative 2, and x plus 5y equals negative 9. I want to eliminate a variable. I'm going to choose to eliminate x because I have a 4x and the other equation is a 1. I can multiply 1 by something to make it 4. But when I multiply by 4, I'm still going to have 4x and a 4x, so nothing eliminates yet. But if I choose to do negative 4, okay, so here's what happens. The top equation is going to remain the same. Sorry, I didn't mean to write that small. And then when I take the second equation and multiply everything by negative 4, I get negative 4x minus 20y equals 36. Because now look what happens. I have a 4x and a negative 4x, which means they cancel. 3 minus 20 would be negative 17. Negative 2 and a positive 36 makes positive 34. Now I can finish solving for the y by dividing both sides by negative 17. And I get y equals negative 2. From this point, it's just like substitution method. Once I know one of the variables, I'm going to pick an equation. I'll just pick the top one. It doesn't matter which one. 4x plus 3y equals negative 2. But I'm going to replace y with the answer that we found. I'm going to add 6 to both sides. I get 4x equals 4, then divide by 4. X equals 1, so my solution is the coordinate 1, negative 2. Now, not every time will we be able to just manipulate one equation. So for instance, on this example, if I want to get rid of x, nothing times 3 makes 2, and nothing times 2 makes 3. That doesn't mean I can't make them match. What I'm going to do is I'm just going to multiply each equation by what the opposite equation has on x. So I'm going to take the top equation times 2, and the bottom one times 3, because now 2 times 3 is 6, 3 times 2 is 6. That would give me my matching numbers. However, a 6x and a 6x will not cancel each other. I need one of them to be negative. It doesn't matter which one, I'm just going to do the bottom, okay? So I'm going to multiply the top equation through by 2. And then I'm going to multiply the bottom equation through by the negative 3 that we chose. Okay. Notice I'm multiplying everything by that same value, okay? Golden rule of math. What I do to one side, I have to do to the other. So now, I'm sorry guys, excuse me. Now look what happens. I've got a positive 6 and a negative 6, that cancels. Negative 10 plus 18 would be 8. 32 minus 48, negative 16. Divide both sides by 8. I get y equals negative 2. And now I'm going to take that value and I'm going to pick an equation. I'm just going to take the top one again. It doesn't matter which one. But I'm going to substitute in what we found y to be. X equals 2, so then my answer is 2, negative 2. Okay, so that's the elimination method, but now I do need to, I'm not going to go through the entire work of a problem. I just want to kind of show you some examples of some things. If I get to like where I have maybe 2x minus 5y equals 3 and negative 2x. Okay, so say my problem looks like this. Look what happens when I go to add my equations. A positive 2 and a negative 2, those cancel. A negative 5 and a positive 5, those cancel. 0 equals 3 minus 3, 0. That is a true statement. 0 always equals 0, so this would be when we would put infinite solutions. Okay, and what would be happening is if I graphed those two equations, if I solved for y and graphed, I would get equation number 1, and then equation number 2 is going to end up sitting right on top of it. That's what's giving me infinite solutions. If I get down to something like 2x minus 5y equals 3 and negative 2x plus 5y equals 7, okay? What happens this time when I add them together? The positive and negative 2's cancel. The negative and positive 5's cancel, leaving me with 0 equals 10. That is not true. It will never be true, so this is when you will put no solution. And again, what's happening there is I would graph equation number 1, and for there to be no solution, that means they never touch. Therefore, the lines would be parallel to one another. Okay. And similar things can happen with substitution method, which I forgot to mention on the last video. But maybe I've got like 2y plus 3. Nope, that's not what I want. Like after I substitute, maybe I get like 2y minus 2y plus 6 equals 6. If the 2y's cancel, that's a true statement. Or if I get something like this, the 2y's cancel and I've got 6 equals 9, that's no solution. Okay, so just understand that you may have a problem on either assignment that if everything cancels completely, or if you end up with like a number equal to itself, that's what we call infinite solutions. Those two lines would lie exactly on top of each other. If we have where all the variables cancel, but we're left with a number, so like my example here, 0 equals 10, that would be a no solution. Or 5 equal to 4, that's not true. Those are no solutions, okay? But as always, if you get stuck and